Hello everyone. Today we'll discuss about heat budget of Earth. I'm Bhumika Saini. I've done my engineering from NIT Jaipur. You can follow me on Unacademy by following this link. Unacademy courses are free of cost, but if you like the course, you can pay an optional fee by following the contribute link on Unacademy. So what is this heat budget of Earth? See, Earth has average annual temperature of about 15 degrees Celsius and it is maintained. How? Because of this heat budget of Earth. This is the balance between incoming solar insolation and the outgoing terrestrial radiation. This maintains the average annual temperature of Earth at 15 degrees Celsius. Right? Now, what is this insolation and outgoing terrestrial radiation? Solar energy received by Earth's surface is called solar insolation, that is incoming solar radiation. Right? Now, what are the factors that affect the solar insolation? First, the amount of solar insolation, it decreases as we move towards poles from the equator. Right now, the factors responsible for this are: one is the angle of sun rays. See, the sun rays are vertical at equator, right? And as we move towards poles, it becomes slanting. So this is due to the decrease in angle of sun's rays reaching the earth. This insolation, it decreases as we move from the equator towards the pole. So equator receives more insolation as compared to poles, right? Also, vertical rays spread over minimum surface area in equator, right? So the intensity of sunlight is more at equator. It increases the energy received per unit area. So vertical rays are there at the equator and they are spread over a minimum surface area. And in case of poles, oblique rays or slanting rays, they spread over a larger areas, right? And that decreases the energy received per unit area. So due to the angle of the sun rays plus the intensity of sunlight is also decreasing as we move from the equator towards the poles. So this is the reason why the insolation is decreasing as we move from equator towards the pole. Now there is another factor, that is sunspot. The solar energy radiated from sun is maximum when solar spot number increases. So there is a cycle of 11 years when there is an increase and decrease in sunspots, right? So the sunspots are maximum every 11th year. So whenever there is this sunspot, the energy radiated from sun is more. Okay, now this is about insolation. Now what is terrestrial radiation? The energy which is received by the earth in the form of short waves from the incoming solar radiation, these are radiated back into the atmosphere by the earth in the form of long waves. Now that is known as terrestrial radiation, right? So these are radiated back by the earth. That is why terrestrial radiation, right? It helps in heating lower portion of atmosphere. Now we'll study the actual heat budget of earth, as we've already studied the incoming solar radiation and the outgoing terrestrial radiation. So let's understand the heat budget of Earth. Suppose the incoming solar insolation is 100 units, right? So amount lost through scattering and reflection, right? Amount lost through scattering and reflection, that is 35 units of this will be reflected back into space, 27 units by cloud, 6 units by dust particles, and 2 units by ice caps and glaciers, right? So the actual units received by the earth and its atmosphere is only 65 units. Why? Because 35 units are already reflected back into the space. You can see it here. This is 100 units of insolation, 6 units, 2 units, and 27 units, that is a total of 35 units are reflected back into the space. So as such, earth receives only 65 units, right? Okay, now let's study this earth is getting 65 units and the 35 units are reflected, right? This we have already studied. So outer atmosphere, it is reflecting 6 units. See this one, outer atmosphere, it is reflecting 6 units. Ice caps and glacier, they are reflecting 2 units, right? This is also known as albedo. And clouds, they are reflecting 27 units. This one, clouds, they are reflecting 27 units. So this 35 units reflected and only 65 units absorbed. Now out of the 65 units, clouds are absorbing 14 units and terrestrial, that is earth, is absorbing 51 units. You can see it here, clouds are absorbing 14 units and the remaining 51 units is absorbed by terrestrial earth. Okay, right? Now out of this terrestrial, that is units, 51 units absorbed by earth, 17 unit is sent back to space. You can see it here, 17 units, it is directly sent back to space out of the 51 units, right? Now 34 units is intercepted by atmospheric gases, dust particles, and clouds, right? You can see this one here, this is the 34 units, 17 is sent back directly to space, 34 unit is intercepted, right? So out of this 34 units, 9 units is intercepted by convection, 6 units by re-radiation, and 19 units as latent heat through evaporation. So 9 units, 6 units, and 19 units through latent heat of evaporation, right? This is how the heat budget of Earth is maintained. So in short, 51 units of solar insolation is received by Earth, right, as direct radiation, out of which 34 through direct and 17 units received through diffuse light. So as such, on Earth, what is coming? 51 units is coming, right? You can see it here, only 51 units is coming. Out of 100 units, 35 is reflected and 14 units then absorbed by clouds. So only 51 units are coming on Earth. Okay, now this 51 units is reflected back to space, right? Now how this heat budget of atmosphere is maintained? See, absorption of atmospheric gases in different vertical zones of atmosphere, that is 14 units. You can see it here, this one is 14 units, right? Now then 51 units by Earth and 14 units absorbed by clouds. So total 65 units, that is total solar insolation received by Earth and atmosphere. 51 by Earth and 14 by atmosphere, right? Now out of the solar radiation received directly by Earth, that is 15 units. I have already discussed, 17 are directed back to the space. Rest 34 unit is absorbed by atmosphere in the form of outgoing terrestrial radiation. Now this 34 unit plus the 14 unit absorbed by cloud, it helps in maintaining the temperature of Earth, that is average annual temperature 15 degree, right? So this 48 unit, it actually helps in maintaining the temperature of Earth. Okay, now there is another concept, that is latitude and energy balance. See what happens. Generally there is a net gain of solar energy in the tropical latitudes and a net loss towards the pole, right? Why? Because we've already discussed that there is direct sunlight at the equator, right, and more of intensity of sunlight at the tropics, and as we move towards the poles, the solar the angle of sun rays is slanting, and the energy received per unit area is less. So there is surplus solar radiation between or in the tropics, and there is deficit solar radiation at the poles, right? So tropical latitudes receive more of sun's energy than polar regions, right? So there is a surplus of energy between 35 degree north and 35 degree south. In this region, incoming insolation exceeds outgoing radiation. So incoming insolation is more than the outgoing terrestrial radiation. Okay, this is the surplus region. This is latitudinal variation in or in the net radiation balance, right? These are the latitudes, and here we have the energy received, right? So there is an energy deficit between 35 degree north and north pole, and between 35 degree south and south pole. So energy surplus between 35 degree north and south, and energy deficit between 35 degree north to the north pole and 35 degree south till the south pole. Okay, so insolation rises sharply, approximately 50 joules at the pole, and terrestrial radiation varies less from this. You need not remember the figure as such, but just remember the concept. So in this particular energy deficit zone, the outgoing radiation is exceeding incoming insolation, and in the surplus zone, the incoming solar radiation is exceeding the outgoing terrestrial radiation. So this is how the latitudinal variation or the energy balance is maintained, right? So as such, energy is transferred from lower latitude energy surplus areas to higher latitude energy deficit areas by atmospheric circulation. Now atmospheric circulation we have already discussed, the different pressure belts, the different cells which are formed due to atmospheric circulation, right? So lower latitude, if there was no atmospheric circulation, lower latitudes would get hotter and hotter, and higher latitudes will become colder and colder. So due to atmospheric circulation, this energy, surplus energy, is transferred from lower latitudes to higher latitudes, right? So this is about the latitudinal variation of this solar energy, right? So we have discussed about the heat budget of Earth. We have discussed how it is calculated, right, and how this heat budget is maintained, right? It is actually maintaining the temperature of Earth at average annual of 15 degrees Celsius. Then we discussed the latitudinal variation, the energy surplus, and the energy deficit areas. Okay, so this was about your heat budget. Thank you.